So this is where we left off last time in chapter 2, where we learned about arrays. And then I showed doing a function with an array, which you had in your homework. So you can have one of the arguments be an array and one of them be an integer. So this PowerPoint is now going to cover more of chapter 5. In particular, we're going to look at some examples first using arrays, some solved problems. I don't always go into the big examples your textbook has, because many times I think you can get hung up in what the problem is rather than in the programming. But the examples in this chapter, some of them are worthwhile so that you can see what's happening in the programming. Okay, so the first one we're going to look at is in section 5.2, which is the hurricane example that they have. So it's an example of reading data files and processing the data that's in that file. So recall in your last homework, I gave you a large text file and you had to read in the data. It was a large file of random numbers, and you didn't know how big the file was, so you had to open the file and read it twice so that you could figure out what array size you needed to create. So this example, the hurricane example, is done a little bit differently, so this is the reason why I'm going to point it out. So this is section 5.2 of your textbook. It says determine which storms are hurricanes using a data file of current storm information. So author gives you a file called storms1.txt, and then you're supposed to figure out the hurricane identification number, the peak winds, and put it into what category hurricane it is. So the first thing with a problem like this, besides understanding what the ins and outs look like, is knowing what the data file looks like. Turns out this is a little bit of a trivial example, but it could be a large file. So this is what the data file looks like. The first column is, I don't actually remember which way. We'll find out in a moment. One of these is the miles per hour column, and the other one is the hurricane ID number. So I could look at this file and tell you what the answer is, but the point is to write a program that could process a large file with 2 columns of information. But you do, again, have to have some knowledge of what the data is in your data file. So if I had made this data file, I would have put the first line of the file saying what the column information is, and then I would have processed everything starting with the second line of the file. But okay, so this is the data file that we're given. Let's look at actually the program. So this is the program. It's the program in your textbook, but to me it's hard to read when all the text is black and all the background is light blue. It's a little bit hard sometimes to follow what's happening in the program. So I have it now where we can compile it and run it and see what it's actually doing. So some things I wanted to point out about the problem is, first of all, I can see that there are 4 lines in that file, but assuming I didn't know how many lines there were in this data file, and I need to create an array, one of the things that you can do is just create an arbitrarily large array, and that's what this program has done. Up above it said define some number n, a constant n. It's capitalized because it's a constant, to be 500. And then there's my defining the file name. So now when I go down here in my declarations and I declare an array called miles per hour, the size of it is 500. Now I won't use all of 500 because I happen to know that there's only 4 lines of data in there, but this is one thing that you can do, is just declare an arbitrarily large array, and then you're covered for however much data that you import. So next, I see a function declaration here, which is a function to figure out what category the hurricane belongs in. So then we go through normal opening the file. So this is how this time we're going to open and read in the file into an array. So I open the file and it says there's an ID, which is an integer, and a miles per hour, which is a not an integer, but you've been given it as a double value. Is that true? Let me check. Yeah, double miles per hour. and the ID is an integer. So I read each one of those lines, and so this is how you handle two columns and writing into two columns of data and writing into two separate arrays. So the first column was the storm ID, and it goes into an array called ID of integers. The second column of the data was the miles per hour of the storm, and it goes into an array called miles per hour. And I read each line of the file, and as long as I read two values every single time, then I'm able to keep reading. While I'm reading it in, I can figure out which is the max speed, and while I'm reading it in, I count how many lines there are in this file, and then I say that that's the number of points in the file, which is going to be used later in the program. So the nice part about this is I didn't have to open the file, close it, and open it once, read how many lines there were, close it, open it a second time, and read in the data. But the downside of doing it this way is that I allotted 500 spaces in memory for my data. Now, memory is cheap nowadays, and computers have lots of memory, so you think, so what? And in this case, it is a so what. But if you were doing large amounts of data, it would matter. You don't want to declare a gigabyte of space to store your array if you don't need a gigabyte of space to store your array. So that's the main thing I wanted to point out about this program. This particular program was the way that it handled not knowing the size of the file. So then the rest of the program is things that you already know how to do. So program figures out what the max is, and this is the function that was called that puts it in a category. So you will pass in some miles per hour, and then you will do if statements to sort whether it's a category 2, 3, 4, or 5 storm, and it will just return your category number. And the rest of the end of the program is some print statements. So I'll run it once so you can see it working. Remember, this was our data file. And let's run this program. Did I save it? Yes, I did. So I will run this program. Called it hurricane sort. And so another thing I wanted to point out that I didn't like about this particular code that the author wrote, because this is the author's code, so that you put out the results, the identification, which is the hurricane identification, the peak, wind, and the category. And then if you look here, the numbers do not align with the header information. So to me, that's bad formatting of your output answers. And that is actually related in the code by the fact that, let's put the code back up here. The author did this. Printf, here's the header information, identification, peak, wind, category. And then the author printed out the various numbers that are associated with those headers. But the author did not use the /t, the slash tabs, which would have created nice even spaces for outputting the answer. Granted, you might have had to have /t/t, but you would have had everything aligned nicely in your columns. So I don't like when you output, try to format your output this way, because you're in the mode of counting spaces between things, and it doesn't work out very well. So please don't do it that way. Use your /t's when you want to format your output answers. Okay, so that was that author example that's in your textbook. The main things I wanted to point out about that was using a different way of reading in a file when you didn't know the length of it, and that's just to create an arbitrarily large array and write to it. So the second example that I'm going to go over is a little harder, which is in section 5.3. It's the molecular weights problem. In this particular problem, let me skip forward for a minute. The program is going to ask the user to enter the chemical formula for one of the amino acids. So they might enter O2C, for alanine, for example, O2C3N1H7. So that would be the chemical formula for alanine. So the program is supposed to ask the user to enter the chemical formula of the amino acid that they're interested in, and then the program will calculate the molecular weight. So the reason I'm going over this problem in particular is because this problem is an example of parsing. So parsing, also called syntactic analysis, but mostly called parsing, is the process of analyzing a string of symbols and then determining what the string of symbols mean. And I'll show you what that, for example, we're going to have a string of symbols that are going to be something like C6H2 or whatever, which is going to be a mixture of digits and characters. So you will have to parse through that user entered string and say, is it a digit or is it a character? And then when it's a character, you'll know it's carbon, hydrogen, nitrogen, whatever. And when it is a digit, you'll know how many carbons there are or how many nitrogens there are in this particular molecule that you're trying to calculate the molecular weight, for which you're trying to calculate the molecular weight. So one of the things this program uses is some various character class tests. So you will need to include ctype.h. So we will be doing some testing. Is it a character? Is it a digit? So I will want to know, am I dealing with a character or a digit? And the user may enter C in lowercase. So we want to make sure that we can convert it to uppercase so that we can output the chemical formula back at the user, make sure the user entered the right things. So this is the main reason I'm going over this problem. I think that from a coding viewpoint, it could have been written a little bit more efficiently, but we will do the example that's in your book, since it's in your book. Okay, so there's my chemical formulas. I think we'll do an example now. So this is the start of the program in your textbook for computing the molecular weight of an amino acid, and we're going to use this particular chemical formula, O2C3NH7. Which one is that? O2C3NH7, the first one, alanine. Okay, so we'll compute its molecular weight. So the user is going to have to enter this formula into the program. It won't be scripted. It'll be all one size script. But there are 1, 2, 3, 4, 5, 6, 7 things that he's going to enter. So user will enter 7 characters from the keyboard. Don't forget to include your C-type header, and for purposes of doing some tests in the program, we've also defined a constant called newline, and newline is our usual newline escape sequence. So let's look at the declaration first, declaration from your book. This is where I emphasize naming your variables, your identifiers with meaningful names, because I had to figure out what D1 and D2 means. So D1 is digit 1 and D2 is digit 2 when we go through our loops later in the program that will test what the user has entered. This is a function prototype for computing the atomic weight. We'll look at the function here in a few minutes. So it's a good idea to be able to compute a hand example at first, because if you can compute what the program needs to do on paper, then you have a good idea when you start writing your code that you can check and make sure your code actually works like you think it should. So if I'm using this chemical formula, what would the atomic weight be? The atomic weight would be 2 oxygens, and that's the weight of an oxygen atom right there, 3 carbons, 1 nitrogen, and 7 hydrogens. And this is the kind of formula that some function has to calculate, and then you will get the answer of 89 point something grams per mole. Textbook never gave the units, but it's in grams per mole. That would be the atomic weight of one molecule of alanine. So let's look at another part of the program. The next part of the program. So there was my function headers, my headers. There's my declarations. I'm at line 17 now. So continuing on, here's line 18, 19 through 22 of the program, which is how to read the chemical formula from the keyboard. And I actually like what this example shows. So here's just information for the user. Enter the chemical formula. And so the user doesn't have to say O, enter, 2, enter, C, enter, 3, enter. What happens is the user enters O2, C3, and H7, and it gets written into an array. So this is how you do that. So the array is called formula, and I don't know how big formula is going to be yet, but what you do is get character, and put the character into formula element k, and then increment k. So, and while you're getting a character and your character is not a new line, you are going to do this. So I think this is a clever way of doing this. Read one keyboard character at a time and put it into an array called formula. And while you're at it, count how big that array is, and then I'll say n is the size of that array. And this is what the array looks like when the user is done. This while loop will continue until the user hits a new line. So formula element 0 will be an O, formula element 1 will be a 2, element 2 will be a C, element 3 will be a 3, element 4 will be an N, and there are 7 elements in this array called formula, and the subscripts or the indices are 0 through 6. So this is where a lot of people, you got to be careful when you're doing loops going forward, that you realize that there are 7 elements in the array and their indices go from 0 to 6. So that's what the user has just put into the array now. Okay, so let's show the rest of the program. I have it here, molecular weights I called it. I'm going to go ahead and put this program in the resource folder on Laulima, because you might want to look at all of it in your own Notepad++ or your own whatever source code program that you're using, so that you can look at the whole thing and play with it yourself. So okay, so there was the declarations I already went over. Here was the part next where the user enters values from the keyboard, and here's where it gets kind of complicated. So this next part of the function gets each element from the array. So current is which element we're currently looking at in the array. And the first test is it an alphanumeric character? So is formula element, the first one that I'm looking at, whatever element in formula, test if it's an alphanumeric character. And then if it's an alphanumeric character, I want to make sure it's an uppercase. So I put back in, I replace the lowercase letter with the uppercase letter. Next thing I want to do is I'm going to call the atomic weight function, and I'm going to compute, for example, if I say it's oxygen, find out what the weight of oxygen is from my function. So we can go down and look at that function for a moment at the end of the program. So here's actually the function. So the function is called atomic weight. It returns a double value, and you pass in an integer, it says. So that's kind of interesting. We'll see what that means. So you can see I've created inside this function an array of elements. There they are. There's their weights. And then what you end up doing is finding out how many of a particular element, how many oxygens will be the first example, how many oxygens there are, and computing the weight and returning the weight. Well, actually you're going to test to see, is it oxygen? That's actually what you're going to do. This test to see if it's oxygen. If it's oxygen, I'm going to return the weight. So back up in the program here. These comments that I have here, these line comments, they're not in your textbook. I added them in after I sat and worked through what this program was doing. This was not an easy program to decipher, I didn't think. So you get the weight of that particular atom. In our first case, it's oxygen. Then I check to see if the next array is a digit. So if I'm on the first element, element 0, formula element 0, I'm going to look at formula element 1 and see if it's a digit. So I could have 2 oxygens, I could have 12 oxygens. So I probably ought to check if I need 2 numbers to know how many atoms of oxygen are in my molecule. So that's what this next part is. Check to see if you need 2 numbers. And if you now, once you have our 2 numbers, you can calculate the weight, which is the atomic weight of atom times how many of those atoms that you have. And that's what this formula does. So you have a tens place and a ones place, and you get the multiplier. So and then finally, after you have the multiplier, you can figure out what the total weight is and return it. And it will go through, and this is part just to print the answers out in the end. This was a complicated if-else structure. I tend to think that there would be a better, easier way to follow this. You're testing to see, do you have a character or do you have a digit? And if you have a digit, do you have a digit with a tens place or not? So is it single digit or a double digit? Then you have to calculate the weight. This was, like I said, not an easy program to get through what was happening here. And these additional comments are mine, and I will put this program on the resource folder on Laulima so you can also look at it. The main reason I went over this program was because it uses C-type functions. So the get character that goes on right here. And it allows the user to enter a bunch of characters all on one line and put it in an array all in one kind of clever step here. I liked that part of this program. And I guess that was the favorite part that I liked about that program, using the different functions that come with the C-type header. Well, let me run the program. I already compiled it. It is called molecular weights. Enter chemical formula. I don't know. C2. I forgot what that one was. H6. No, C2. And H7. I don't know. I made one up. It wasn't a C2. It was O2. Let's do the exact one so it proves that it checks. It was O2C3NH7. O2C3NH7. And I entered it in lowercase, and I want to see it written in uppercase. So, I have some additional. I was checking. I put an additional print in there so that I could see oxygen's weight, carbon's weight, nitrogen's weight, and hydrogen's weight. There's the formula, and there's the total molecular weight. This was a check step I put in there to see what it was doing. That's what the function does. It returns how many, the weight of the oxygen. Yes. And okay, so it works. It was nice, but a bit complicated the way it was done. I still think there's a better way to do it, like maybe a case structure might have been a nicer thing. So next section in your textbook has to do with statistical methods. I think this section gets really hung up in the math, standard deviations and means and modes, and I think you can get lost in the math in this section, and this is not a statistics course. But the main point of this section, I think, should have been making your own header files. So I think I will delay this section until later in the semester because I consider it a more advanced topic, and this section of your book didn't treat it well, but treated the math well instead. So we will delay this section. Also at that time we will look at macros. So macros are something that you put in the preprocessor directives as well, and we skipped that section when it was introduced in an earlier chapter in your textbook. But I would like a little bit later, towards the end of the semester, we will take a closer look at all of the preprocessor directives, which means whether it's a header, making your own header files, or making your own macros in the preprocessor directives area. So you can pass section 5.4 for now. I think that's 5.4 and 5.5. So moving on ahead, the next section, 5.6, is about sorting algorithms. There's a lot we can say about sorting algorithms, but it is a very common task in programming to find a particular item in an array, or to sort it from an ascending order or descending order. So one of the reasons you would put it in ascending or descending order is because algorithms to find something in that list work better if the list has been sorted. So these are at least the first two of these we're going to look at. One is just a sequential sort. So you just sequentially go through your array or your list, and you try to find the item that you're looking for. This is a very inefficient brute force way of finding an item that you're looking for in a long list or a long array. Somewhat better is to do what's called a selection sort algorithm. It puts your list or your array into either ascending or descending order, and then your algorithm for finding a particular item can work much faster. For example, if you're looking for a particular number, you can sort it from highest to lowest or lowest to highest, and once you find that number you don't have to continue searching through the list. So that can make your algorithm go much more efficiently. And then the third sorting algorithm that we're going to look at, probably not in this presentation, maybe the next one, is the binary search. It's clever, but it has some rules associated with it. And here is my cartoon pointing out that a common task is to find something, and so this is a joke about finding something using search engines. You can imagine that search engines from Google or wherever have been really optimized to be efficient. So let's look at the first algorithm, which is just the sequential sort, the brute force method. So here's my brute force method. If your array is unordered, you must look at all of the elements. If the list is ordered, perhaps you can stop when you find the match that you're looking for. So here is a function, the function that will just look for a particular element. So my function is expecting to have an array passed to it. I expect to know the size of the array, and this is the value that I'm looking for. So if I have a large array of numbers, let's say I have 100 numbers and I want to find the number 25, this is going to go through all 100 numbers until it finds the number 25. Excuse me. And this is how you would do it. Basically, you Oh, and what I'm going to do is if I find the value, I'm going to return its position in the array, so its index number. If I don't find the value, I'm going to return a -1 because there's no -1 associated with a position in an array. So it's pretty straightforward. You just go through each element of the array, and while the element value does not match the value I'm looking for, I will increment my going through the array. And if I'm not done through the whole array, then I will return the index. So the index is either -1 or the index is the place where you found the number. So that's a pretty simple function. Let's show the function in the calling program now. So here's my main calling program. I have an example. I made a function, an array called myData. It's just an array of 6 numbers in arbitrary order. Then I called my function, which was called search1. Well, that's the prototype for it, for search1. And the only place I call the function is right here. So I'm looking for the number 8. I call the function. I pass in my array. My array is 6 values long. I'm looking for the number 8. And I'm going to print the answer. A is in position whatever, and then my function's going to tell me what position it's in. And just for the fun of it, I decided to print back the array because I wanted to make sure that it was working correctly, and I did see my array. So let me run this program. I do believe I already have it compiled. The current compiled value is right there. Yes, there it is. So it says number 8 is in position 3, and there was my original array that I put in. So yeah, it works correctly. There it is again. I called the function. Well, let's see the whole program. There's the whole program. There's the function at the bottom. Oops, that's a different function. My program has more than one function in it. Here's the function called search1 that searches for a particular value. And this is the function that we're going to use in our next part of this lecture, which is putting it in order. And here's my main calling function. So I create my data array right there. This is what we're going to talk about next. But there's my function prototype, and there I said I called my function search1 to find where number 8 was in my array that's 6 elements long, and it output the right answer that 8 is in position 1, 2, 3, whoops, 0, 1, 2, 3. So 8 is in position 3, which is what it said. Yes, 8 is in position 3. Okay, so, well, with index 3. Okay, so now let's look at the next sorting algorithm. This one's a little bit more interesting, kind of clever, I think, also. It will execute much faster than a brute force algorithm will. It's called the selection sort. It works by locating the smallest value and moving it to position 0, element number 0, or the element with index 0. And then it will find the second smallest number and put it into element 1. And it will continue until all the elements have been placed in their proper order. So this algorithm requires that you swap elements in the array, which generically can be done like I have shown, like I started to show in my example here. So let me finish this example up. So if I have an array, here my array only has 2 elements in it, a number 5 and a number 7, and I'm going to say that's the mth element and that's the kth element. In this case, m happens to equal 0 and k happens to equal 1. And so what this little piece of code does is it says hold gets the mth element. So initially hold gets this value of 5. And then it says I'm going to well, since m is 0, then it says that x element 0 is going to get this value. So it's going to put 7 in the first value. So it's going to be x element 0 is going to get 7 now. But remember, I remember that this whole thing is what it's doing is saying, well, there used to be a 5 in that position 0, but now I just overwrote position 0 with the 7 because I'm trying to swap values. So now element 0 has a 7, but actually this one still has, like right now at this point the array has 5 and 7 in it. At this point the array has 7 and 7 in it. But I stored somewhere the value of 5, and now this one says, this next line says that that element will get 5. So now my array now has 7 and 5 in it. So that's pretty much how you swap two elements in an array. Now it doesn't have to be, like I've shown over here, it doesn't have to be 0 and 1. It could have been, maybe I want to swap 5, 3, 2, 8, 7. Maybe my array is like that. And these are the two elements that I want to swap. So that's why I have it as m and k, so that I can swap any two elements. But the main thing is that you have to have this little holding place, because you'll take this element, put it into that place, but you had to store what that value was somewhere so that you can put that value back into that place. So this is just how you do the swap. That's the swap. Swap two elements. So now let's look at the algorithm itself, what it has to do, because we want to put everything, we want to put it into ascending order, which is the smallest to the largest. Let me show you an example first before we do the actual algorithm. This isn't in your textbook anyway. So here's my little, well, it's not well developed in your textbook. This one's a little better than some. Okay, so here's my original array of numbers that are in some weird order, and I want to put it into ascending order. So the first thing I have to do is find the lowest value and swap it with position 1. So that's what I do. 1 goes there, 5 goes there, they swapped positions. So now I'm done with the first element, this column right here. I'm done. So now my algorithm just looks at this part next, goes through the same thing, finds the lowest value, whatever it is, and swaps it with this position. So 2 and 7 will swap. Now it's like that. So now I'm done with these first two. I don't look at them anymore. I look at these last elements right here, and I find whoever the lowest value is, and I swap it with this position right here. So I do the swap right there. So now it's like that, and you continue on, etc. So that's how you do it. You go through the whole thing, find the lowest value, swap it into position 1, then find the next lowest value, swap it into position 2, or the second position. Find a third lowest value, put it into the third position, which is element 2, etc. So now let's look at the real code. Example from your book, which I typed up and walked through. But I think it's, so this is the actual function that will sort it into ascending order. Recognize here there's the swap part. So really the first part of the function must find what the lowest value was and then do a swap. And then shorten the size of the array, look for the lowest value again, and do a swap. So actually, rather looking at it, trying to read through it the way it's written right now is a little bit difficult, but I thought it was kind of worthwhile. I will just walk through here what's happening with the J's and K's. Here was my original, here's my original sequence of numbers that I want to put into ascending order. So I come into the loop right here, or come into my function right here. Notice it doesn't return anything also. It just reorders the array, but it doesn't return anything. So I'm going to come through the loop the first time. Initially k equals 0, and you're going to do this loop 4 times because you're going to work on the remaining 5 digits. You're not going to work on the first. And originally m and k equals 0, but this part is a little confusing up here, the loop structure, so I thought it was most beneficial really just to walk through it. So initially, if you look at the program, initially k equals 0, k equals 0, m and k are the same, and then I enter this loop and it says for j equals k plus 1. So what I'm doing is saying now j equals 1. In this first pass going through this program, k equals 0, j equals 1. So this is the 0th element and this is the first element, and that's what it's looking at. So then I do this test. Is the array element 1 less than the array element 0? So I say, is 5 less than 7? That's the question mark. And the answer is yes. So since it's yes, yes, basically we're going to not do a swap. No swap. So then I'll go on and I'll say, is j equals 2 now? So is 5 less than 2? J equals 2, we're right here. And I say, is 5 less than 2? Yes. So 5 is still the, oops, sorry, no. No, 2 is less, so we better do a swap. So swap, right? So at that point, x element 0 swaps with x element 2. So this is what that swap is right here. This is the swap function that I showed you on the other page. At that point now I have 2, 7, 5, 8, 9, 1 in the array. So I continue on. J equals 3. So that is, remember I'm still at k equals 0. I haven't increased this outer loop iteration yet. So I'm asking now, is k is 0? Well, 0 is now 2. The 0th position is now 2. I'm asking, is 2 less than 0, 1, 2, 3, 8? Is 2 less than 8? Yes, it is. So no swap. Got the lowest in the front. Is now j equals 4. Is 2 less than 9? Yes, no swap. J equals 5. So is 2 less than 1? No. Do a swap. So that means I'm going to swap these two positions. And so now I have 1, 7, 5, 8, 9, 1. I'm done now with 2. I'm done now with the first pass. So I'm done with k equals 0. I'm done looking at, I've put the lowest number right now there. I'm going to start here and do the same process again. So now k equals 1 and j equals 2. So I'm going to look at these first two numbers first. And then I ask my question. Again, is 7 less than 5? So that's what this question is right here, right? J is 2. Oops, yeah. Is, yeah, okay. Is 7 less than 5? Etc. So we'll go through this again. Is 7 less than 5? No. So we got to do a swap. I missed something here. Let me think that for a second. Oh yeah, that's correct. No, so you have to do a swap. So now when I do the swap, I now have, whoops, come on, pen. So I now have 1, 5, 7, 8, 9, 2. And I continue. J equals 3. Is this number less than this number? Anyway, you continue in the same fashion, and in the end you should have your array in order. So let me go back to my program. Here is my function that sorts in ascending order, and here I'm going to go ahead and call the function. Notice that calling the function doesn't return anything, but now when I print the array right here, it should be in ascending order. So let's save this and recompile. Move my keyboard back here. Yes, originally 8 was in position 3. I still left that in, but now you can see my array is sorted in ascending order. Okay, that's 46 minutes of a YouTube, which I understand people say my YouTubes are very long, so I should pause this one, stop this one here. We will look at binary sort, and we will look at two-dimensional arrays in the next YouTube.